What are the properties of exponents, and then how can I use the properties of exponents to write equivalent expressions? So a couple just quick little terminology things. An exponent is that actual number that's raised up above. Number, so the n here would represent the exponent. The base would be the x here. And then the power is kind of the whole combination of the exponent and the base, the whole term. Like x to the n is the power, the base here is x, and the exponent is n. But the power would be x to the nth power. Now, product of powers property. So if I have a to the m and I multiply that by a to the n, that's actually the same as a, and if I just add the exponents together, m plus n. For example, 5, so if I had 5 to the third times 5 squared, that's actually going to be 5 to the third is 5 times 5 times 5, right? Times 5 squared, so 5 times 5. So if you actually wrote this out, because in multiplication, the order you multiply doesn't matter. This actually is 1, 2, 3, 4. This is 5 to the 5th. Oops. And so that's really, if you think about the original problem, it's the same as 5 to the 3 plus 2, which is m plus n. Now, the next one is similar to that one, so don't get confused. This is the power of a power property. This is where if I have a to the m, and then that whole quantity is then raised to another exponent. In that case, you actually multiply your exponents instead of adding them. So instead of it being 3 to the third times 3 squared, this is 3 to the third squared, which would be written as 3 to the third times 3 to the third. In which case now I'm multiplying exponents and I could add them together. 3 plus 3 is 6, but I could also write that out as 3 to the third, 1, 2, 3, 3 times 3 times 3, times 3 times 3 times 3, which is 3 to the 6th. So again, 3 to the third squared is the same as saying 3 to the third times 3 to the third, in which case I would add the exponents together, which you could also write as 3 times 2. So 3 to the 3 times 2 would be 3 to the 6th. And then finally is quotients of powers property. So the third one is, instead of multiplying, I'm dividing two powers. So I have a to the m divided by a to the n. In that case, I actually subtract my exponents. So for example, if I have 3 to the 5th divided by 3 to the 3 squared, or 3 to the second, you could write that as 3 times 3 times 3 times 3 times 3, so 5 3s divided by 3 times 3. Now, you can actually cancel these out, because times 3, and on the top end, the numerator and denominator in this case, equals 1. And this equals 1. So we end up with 3 times 3 times 3, or 3 to the third over 1, which would be the same as 3 to the 5 minus 2. So m minus n, 5 minus 2. And just kind of a little foreshadowing into the next lesson where we start talking about negative exponents, because if you're subtracting, you could end up with a negative exponent, like b to the third, b times b times b, over b to the 5th, b times b times b times b times b. These cancel out. You end up with 1 over b squared, but that would be the same as b to the 3 minus 5, and 3 minus 5 is negative 2. So you would then think that b to the negative 2 equals 1 over b squared. So a negative kind of means like it's in a denominator. It would be the same as the positive exponent, but in a denominator. We'll talk about that a little bit more later. Just wanted to kind of foreshadow that a little bit. What are the properties we talked about? What are the properties of exponents? We got the quotient of powers property, the power of power property, and the product of powers. And how can I use these to write equivalent expressions? Again, you would either add, multiply, or subtract your exponents and finding the equivalent expressions.